Our universe is a massive and ever-changing stage for cosmic events that are hard to imagine. Out of all these events, few are as amazing as when galaxies collide. These huge structures, made up of billions of stars, gas, and dust, do a kind of gravitational dance that lasts for billions of years. Imagine a crash so big, so strong, that it could change the fate of entire galaxies. Andromeda, our galactic neighbor, is on a crash course with us. This meeting in space, although billions of years away, has already started. The proof is in the faint whispers of stars, thrown across huge distances like messages from space. Come with us as we explore this epic cosmic dance. The huge distances between galaxies might make you think the universe never changes, but this cosmic ballet is far from still. The Milky Way and Andromeda, separated by a massive distance of 2.5 million light-years, are going to collide head-on. This prediction, based on decades of looking at the stars and clever simulations, is no longer a prediction for the far future. Evidence shows the merger has already started. The outer parts of these galactic giants aren't on their own anymore. They're in a gravitational tug-of-war, swapping stars and changing each other's shapes. As time goes on, the pull between the Milky Way and Andromeda will get stronger, pulling them closer together in a series of close calls. Each close call will leave its mark on these galaxies, messing up their spiral arms, setting off waves of new stars being born, and finally leading to their final hug. When galaxies collide, it's not a sudden, destructive event. It's not like stars and planets suddenly crashing, but a slow process controlled by gravity. As galaxies get closer, their gravity starts to affect each other. This creates tidal forces like the ones that cause tides on Earth, but much, much bigger. These forces stretch and twist the galaxies, pulling out long streams of stars and gas that look like beautiful arcs in space. Stars, once stuck in their galaxies, are thrown onto new paths, some even escaping their galaxies completely. Gas clouds, squashed together by gravity, burst into new stars, making the merging galaxies shine with the light of these newborn stars. This is gravity's dance, a cosmic ballet that takes place over a very long time, shaping the universe one galaxy merger at a time. In the massive expanse of space, stars aren't always stuck in their galaxies. Some stars, sped up to incredible speeds, escape the pull of their home galaxies and travel alone through intergalactic space. These superfast stars, called hypervelocity stars, hold the key to understanding the early parts of galaxy mergers. Hypervelocity stars aren't just cool things in space, they're messengers from faraway galactic encounters. Their paths, like breadcrumbs in space, can be traced back to where they came from, showing us where and how galaxies interacted in the past. By studying these stars that have been thrown out of their galaxies, astronomers can put together the history of galaxy mergers and learn about the processes that shape the universe. Finding hypervelocity stars has completely changed how we understand how galaxies move and interact. Their existence gives us strong evidence that the Milky Way and Andromeda are merging. The escape velocity of the Milky Way, the speed something needs to go to escape its gravity, is a massive 550 kilometers per second, but hypervelocity stars have been seen going faster than 1,000 kilometers per second. What forces in space could make these stars go so incredibly fast? The answer is in the middle of our galaxy, where a supermassive black hole, millions of times heavier than our sun, lives. This giant thing, with its massive gravity, acts like a slingshot in space, throwing stars into the depths of space at incredible speeds. This star-throwing process happens when a binary star system, two stars orbiting each other, gets too close to the supermassive black hole. In this cosmic game of tug-of-war, the black hole's gravity captures one star while the other is thrown out at an incredible speed, becoming a hypervelocity star. Finding hypervelocity stars gave astronomers a new way to study how galaxies interact. Stars that came from Andromeda were the first real proof that the merger is happening. These stars from another galaxy, carrying the chemical signatures of their home galaxy, are like cosmic calling cards. Using information from the Gaia Space Telescope, astronomers found hypervelocity stars that came from Andromeda. These stars, traveling faster than the escape velocity of the Milky Way, couldn't have come from our galaxy. Their presence shows that the Milky Way and Andromeda are already dancing together. These stars are the first wave of a galactic merger that will take billions of years. The merger with Andromeda will change the Milky Way forever. turning our familiar spiral galaxy into a massive elliptical galaxy. This transformation, although taking billions of years, will be a time of intense activity, with starbirth, galaxy crashes, and the eventual merging of supermassive black holes. As the Milky Way and Andromeda get closer, their gravitational interactions will become more and more disruptive. The Milky Way's spiral arms, once graceful arcs of stars and gas, will be twisted and eventually destroyed. Gas clouds, squeezed by gravity, will ignite with bursts of star formation, lighting up the merging galaxies with the light of new stars. This time of intense star formation won't last long. As the galaxies continue to merge, their gas will run out, and star formation will stop. The Milky Way, once a lively spiral galaxy full of young stars, will become a calmer elliptical galaxy, with mostly older, redder stars. The merger of the Milky Way and Andromeda will be a slow and beautiful event, a cosmic ballet happening over billions of years. The two galaxies will pass through each other several times, their gravitational pulls getting stronger each time. Stars will be thrown onto new paths, gas clouds will crash, and the galaxies themselves will be twisted out of shape. During these close encounters, the night sky will be alive with a dazzling display of celestial fireworks. Streams of stars will be pulled out from each galaxy, making bright bridges across the space between them. New generations of stars will be born from colliding gas clouds, their light making the merging galaxies shine brighter than they have in billions of years. The supermassive black holes at the hearts of the Milky Way and Andromeda, destined to merge in a huge event, will also play a big part in the merger. As the Milky Way and Andromeda merge, our solar system will be caught in the middle of their gravitational fight. The Sun, along with its planets, will be thrown onto a new path, its place in space changed forever. While it's very unlikely that our solar system will crash into another star system, the changes in gravity will have a huge impact. Simulations suggest a 50-50 chance of being thrown outwards, away from the center of the galaxy, into the emptier outskirts of the new Milkdromeda galaxy. This move in space wouldn't necessarily be the end for life on Earth, but it would change our view of the night sky a lot, with the constellations we know replaced by a new arrangement of stars. The Milky Way merging with Andromeda reminds us of how massive and active the universe is. It shows that we're part of a cosmos that's always changing, where even things that seem permanent like galaxies are affected by gravity. This cosmic event, though billions of years in the making, gives us a peek into the powerful forces that shape the universe. Studying galaxy mergers, helped by new technology and hardworking astronomers all over the world, continues to teach us new things about how galaxies evolve and the basic laws that control the cosmos. Every new discovery helps us understand our place in the grand scheme of the cosmos. The Milky Way merging with Andromeda isn't the end of our galaxy's story, it's just the start of a new chapter. The new Milkdromeda galaxy, a massive elliptical galaxy, will keep changing over billions of years, its stars getting older, its gas running out, and its supermassive black hole hiding in the middle. The story of this merger will be written in the stars, in how the stars are spread out, in how gas clouds move, and in the faint glow of the cosmic microwave background radiation. By studying these leftovers from a time long ago, astronomers in the future will be able to put together the history of Milkdromeda and learn about the things that shaped our galaxy. The Andromeda-Milky Way merger reminds us that the universe isn't still, but a dynamic and ever-changing place. It's a source of wonder and inspiration, reminding us of how big and beautiful the cosmos is and our place within it.